Hi everybody, I'm Professor Rad, and today we're going to talk about box and whisker plots. So the box and whisker plot is one way that you can visualize the data from a 5-number summary. Sometimes a box and whisker plot is referred to only as a box plot. The whiskers are still there, but it's just shorter to say box plot. So sometimes you might hear it referred to as a box plot. Essentially, what we're going to do when we create our box and whisker plot is we're going to create some boxes where the middle portion of the 5-number summary is, and then we'll create whiskers where the outer portions of the 5-number summary is. There are two types that you can make, one where your dataset has outliers and one where your dataset does not have outliers. So we're going to do two examples in this video. In the first one, there are no outliers in the dataset. And in the second example, there are. So let's get started with this first example. It says that the ages of the senators of the 118th Senate have the following 5-number summary. There are no outliers in this data set. We're going to create a box plot for these. So the first thing I'm going to do, because I have a tendency to forget this part, is label everything, and then I'll go ahead and graph the data. So these are the ages of the senators in the 118th Senate. So I'm going to say senator ages for my title. And I'm going to put 118th Senate in parentheses. And then for the horizontal axis, I notice my data is labeled with years old. So that's how I'm going to label the horizontal axis. Now, one of the things that's a little peculiar about a box and whisker plot is you'll notice there's no vertical axis here. So these lines that I've provided are just here to kind of help us draw straight lines, basically. So when you create a box plot, you might not even have those vertical lines or grid space there. You might just get that horizontal axis. Now, I also want to familiarize myself with how these are spaced out before I begin to plot some data. So I notice the first value is 30 and the next one is 36. So from 30 to 36 is a distance of 6 and half of 6 is 3. So that must mean this is 33. So if you have trouble with your scale on your horizontal axis, this is a thing you want to do before you start plotting numbers to make sure you get things in the right spot. So if you want to, you could go ahead and fill in all these missing numbers here. You don't have to, but again, if you have trouble identifying that spacing, it's not a bad idea to do that. So I'm going to do that just so we have it here for reference. 11, so 51, 7. And again, all I'm doing is I'm adding 3 to each of these spaces. So 72 plus 3, for example, is 75. And then what that means is since each of these is a distance of 3, when I'm plotting whole numbers, I want to be careful to make sure I'm plotting them appropriately. So 61 is going to be about a third of that distance, and then 62 would be the next third. So just be mindful of how the grid is set up before you go to plot numbers. And now we can go ahead and do that. So when I create a box plot or a box and whisker plot, I do the box portion first. The box portion is made up of Q1, the median, and Q3. What I'm going to do is I'm going to go to each of those numbers and draw a vertical line. So vertical is up and down. I'm not going to connect it to the axis like you do with a bar graph. It kind of hovers above. But however big you make your line is up to you. So if you want to draw a little line, you can, or if you want to draw a bigger line, you can. It just shouldn't be sitting on the floor. So I'm going to go over to 56, which is right before 57. And I'm going to draw on this grid one that's 3 long. But again, it doesn't matter how big you make it. Okay, so you can make a smaller box plot or a larger one. Then I have 65, so that's going to be just before 66. And 71, which is just before 72. When you're creating these lines, you do want them all to be the same size. So if you create this one really short, then you want to make sure these are also shorter. And then we're going to connect them across the bottom and across the top. And that makes our boxes. Next, since there aren't any outliers, we're going to go ahead and create the whiskers. So to do the whiskers, I'm going to do the same thing with the minimum and the maximum, but I'm going to make shorter lines. They can be the same size, but typically you see them with shorter lines. And then I'm going to connect them to the boxes like the whiskers connect to a cat's face. So I'm going to go over to 35, which is just before 36, draw my shorter line. And then I'm going to connect it over to those boxes. Then I'm going to go to my maximum of 89, which is just before 90. So draw a short little line there. And then also connect it to those boxes. And there we go. That is our box and whisker plot. Now, since these are our notes, I'm going to leave some notes to my future self so I know how I created this. So I might put a note on the side, the size of the box doesn't matter. But what I'm definitely going to put here for now is that this came from the minimum, this came from Q1, this came from the median, this came from Q3, and this came from the maximum. So that way when I look at this in the future, I know where each of these lines came from and how they relate to that 5-number summary. Now, what the box and whisker plot does is it shows us kind of the density of the quarters of the data set. So for example, I like to think of it as like 100 people. So I've divided my 100 people up into 4 rooms. So there are 25 people living in this room, pretty spaced out. 25 people living in this room, they're pretty close together. 25 people in this room, close together, but not as close as they were here. And 25 people on this outer edge. So these 25 people have a lot of space, and these 25 people are pretty close together. So that gives me a sense kind of the density of the data set, where the data is clustered with regards to those quartiles. All right, so let's go ahead and look at an example of a box and whisker plot that has outliers. Portions of this are going to be the same, and some parts are going to be different. So in this example, it says, in 2007, Vlogbrothers Hank and John Green started a YouTube project called Brotherhood 2.0 in order to reconnect as adult brothers living in separate states. The lengths of their first 50 videos in minutes are given in the table below, and a 5-number summary is found. So sometimes if you're creating a box and whisker plot, they might just give you the data. And so in order to create the box and whisker plot, you have to find a 5-number summary first. But in this case, they've already done that for us. It says the values of 1.50 minutes and 4.92 minutes were identified to be the only outliers. So we know there are outliers in this data set, so we're going to have to bear that in mind when we go to create the graph. The way that I'm going to start is the same as before. So I'm going to make sure I give this graph a title and then also label that horizontal axis so I don't forget to do it. So let's see, these are Brotherhood 2.0 videos. So that's what I'm going to call it. Maybe I'll call it video lengths. And by the way, Hank Green has garnered some fame on TikTok, or Hank founded SciShow, and Hank and John did Crash Course. So if you've used any of those videos before, these are the guys who started that, and they got their start on YouTube with this Brotherhood 2.0 project. And then we'll go ahead and label this horizontal axis. And these are the lengths as been measured in minutes. So I'm going to call this minutes. All right, so we've got kind of our mise en place set up here. We've got everything set up in order to graph. Next, let's make sure we understand the scale of our axis. So we have 1, 1.5, 2, 2.5, and so on. So it looks like each of these lines are going to be 0.25s. So I have to keep that in mind as I go and graph the data. So for Q1, we have 2.75 minutes. So 75 is a quarter, so that's going to be one of our lines exactly. So here's 250, so 275 is this line. So I'm going to go ahead and draw my vertical line there. So the box portion is the same whether or not you have outliers. 3.5 is also a line. So here's my 3.50. 3.1 is not. So I kind of have to estimate where that is. So if this is 25, so 3 and then 3.25, then if I split that up into counting by fives, right, this would be 5, 10, 15, 20, 25. So 3.1 is the same as 3.10. So if this is 3.05, this would be 3.10. So I'm going to go up over here and draw my vertical line. Then I connect across the bottom and connect across the top. All right, so those are the boxes of our box and whisker plot. Again, if you want to give yourself a little note, you could say this was Q1, the median, and Q3. So when we look at this later, we know how we created it. Next, before I draw the whiskers, I have to plot my outliers. So 1.50 minutes and 4.92 minutes are outliers in this data set. So to indicate that they're outliers, we're going to keep them disconnected from the rest of the graph. Remember, an outlier is a data value that lives outside the rest of the data. So I'm going to go over to 1.50, and kind of like where we would put that line for the minimum, instead of a line, I'm going to put an X. So the outliers are going to get graphed with an X. Same thing with 4.92. Okay, so 4.92, let's get a sense of where that might live. So this is 475, and then I can kind of count like fives again. So 75, 80, 85, 90, 95. So this is about where 4.90 would be. So I'm going to go just a little bit to the right of that. Especially given the graphing space that you have, sometimes you just have to make some approximations. So as long as we're in the right ballpark, I'm going to be okay with that. All right, so we've got our outliers. Now notice that the outliers were the same as the minimum and the maximum. Sometimes your outlier is, maybe you don't have any high outliers, maybe you just have low outliers. In that case, you would go ahead and graph the maximum like normal. So if this wasn't an outlier, then I would graph it just like I did up here. But since it is an outlier, now we have to do something different. Same thing with the minimum. If I had an outlier up top, but I didn't have an outlier in the bottom, then I would just graph the bottom like normal with the minimum. Instead, what we're going to do is we're going to go up to our data set, which is presented in order, it looks like from left to right, is how they sorted these. And I want to look for the first number that is not an outlier on either end. So 1.50 was an outlier, so I'm going to kind of X that out since we graphed it. And the next number is 1.75. So they told us these were the only outliers, so I know 175 is not an outlier. So that's the number that I'm going to graph. So 1.75, I'm going to graph it just like as if it were the minimum. Then I'm going to do the same thing on the upper end. So 4.92 was identified to be an outlier, so I'm going to X it out. 4.32 is not an outlier, so that's the next one I'm going to graph. That one's a little bit trickier. So here's 4, 425. So if I'm counting 25, 30, 35, 40, 45, 50. So 25, here's 30. So 4.32 is going to be in between those two lines. So 4.32 is going to be about here. And then I connect them. There we go. That's how we graph the edges of this when we have outliers. So I'm going to put a note to myself, these X's were outliers. And then over here, I'm going to put next lowest, since it was the next lowest number after 1.50. And here I'm going to put the next highest. Since it was the next highest number before 4.92. So that's how you graph a box and whisker plot if you have outliers. And again, what this helps to indicate is that about 25% of the people are in this tiny room, and about 25% are stretched out more in this longer room. It also helps to give us a sense of how far away from the data the outliers were. So for example, this 1.50 was not so far away from the next lowest number. They were pretty close. This outlier on the right was a little bit further away. So it kind of gives you a sense of how strange the outliers were if you compare it to the rest of the data. So that's going to wrap up this video on box and whisker plots. In the next video, we're going to start to do some more analysis with graphs and talk about different shapes that graphs can have. So I'm looking forward to seeing you then. In the meantime, have an excellent day.